Welcome to Van-Gelder Tutoring. This is the Atom Part 2, where we're going to be going over isotopes as well as some practice questions looking at isotopes as well as the content covered in the Atom Part 1. If you haven't yet seen the Atom Part 1, there is a link on screen now to take you right there. An isotope is an atom of an element with the same number of protons but a different number of neutrons. This is one of the definitions that you need to know. Asking the definition of an isotope is one of the most common first-year A-level questions. It's a one-mark question and an easy one to get. In terms of what that means, take for example carbon. Any atom that has 6 protons is always going to be carbon, and according to the periodic table, carbon has a mass of 12 and a proton number of 6, which means carbon must have 6 neutrons. An isotope of carbon is, for example, carbon-13. Carbon-13 has a mass number of 13 and a proton number of 6. This means carbon-13 must have 7 neutrons rather than 6. This means carbon-13 is an isotope of carbon-12. Isotopes of elements have the same chemical properties as they have the same number of protons and electrons. However, they can have different physical properties due to them having a different mass. Most elements have naturally occurring isotopes. One of the other most common ones you'll see is chlorine-35 and chlorine-37. Chlorine always has 17 protons. We can see here how many protons, neutrons, and electrons both isotopes of chlorine have. You need to be able to calculate the number of protons, neutrons, and electrons in different isotopes, just like you did with elements and ions in Part 1. Now, here are some practice questions. The practice questions will cover content from Part 1, as well as some content covered in this video. Pause the video here, and then we'll move on to the next set of questions. This is Part 2 of the questions. Pause the video again here, and then we'll move on to the answers when you've finished. So, here's the answer to question 1. As we can see, we have a list of all of the elements, their mass, protons, neutrons, and electrons. Now, if you were quite savvy, you could have used your answers to question 1 to also determine the answers to question 2, as the only thing that changed was the number of electrons. For question 3, we can see how selenium is denoted here, with 79 mass number and 34 as its proton number. For question 4, the answer is of course protons, neutrons, and electrons. Now for question 5, this isn't quite marked how a lot of students think it is. Students tend to think it's 1 mark per thing written that is correct. The way this actually works is next to proton, for example, if you put relative mass as 1 and relative charge as +1, that would be worth 1 mark. However, if you got the relative mass wrong and the charge correct, you wouldn't score any marks. Another common way students lose marks in this question is they don't put the plus or minus next to the relative charge for protons and electrons. And lastly, if you wrote 0 for electrons, you've also lost that mark there too. Atomic number is defined as the number of protons. If you put the number of protons and electrons, you would still gain the mark. To calculate the number of neutrons, it's simply mass number minus proton number. For question number 8, they have the same chemical properties because they have the same number of protons and electrons, whereas for question 9, the reason they have different physical properties is because they have a different mass number. And lastly, for question 10, an isotope of an atom of an element with the same number of protons, but with a different number of neutrons. And that is the end of this video. This has been Van-Gelder Tutoring. Thank you for watching. Hit the subscribe button to support the channel and support me in making more videos in a way that is free for you to do. Thank you.